Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you the circular motion in vertical plane. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. So today's topic is circular motion in vertical plane. So what is the example of circular motion in vertical plane? Giant wheel in a fair. The motion is up to down. That is circular motion. If you tied a stone by a string and wheel in up and down, that is vertical plane, means up and down, up and down. This motion is vertical circular motion in vertical plane. Giant wheel in a fair is the example of circular motion in vertical plane. Very important topics for both NEET and JEE Main and Advanced. The stone is tied by string, and if the stone is wheeled in vertical plane, then what is the different tension and velocity at different position? I will discuss elaborately. So this is a vertical circle, and a stone is tied by string, is wheeled along the vertical plane. Now we want to find the tension at different position, and what is the minimum velocity required at here, so that the particle or stone can complete one rotation. At any general case, suppose this is angle theta, and mass of the m is the mass of the stone, and r is l or r, l equal to length of string, length of string. Suppose at any angle theta, what is the tension of the string? Here different force act, weight act in this direction, and centrifugal force. Suppose this velocity is v, so centrifugal force act along the string in this direction, which is mv square by l. So tension act in this direction. This is tension at b. This is the tension. Now l is the length of the string. So first find what is the tension at b. Tension at b will be mg. If this angle is theta, then this is theta. So component of the weight along this direction is mg cos theta. So tension should be equal to this plus this. Tension at b equal to mg cos theta plus mv square by l. Fine. So this is the tension of the string. This should be equal to this plus this, because this tension balance the two force. The stone does not move this direction and this direction, so this along this direction net force will be 0. That's why this equal to this plus this. The stone does not move along this and this. The stone is wheeled along the vertical circle along this direction. So if the velocity is at point is vb, then we put here vb. So vb mv square by r. Now we get the tension at this and this, just putting the different angle. So for position a, what is the theta equal to 0 degree. So if we put theta equal to 0, because we start from here, theta equal to 0 means at position this. So at position this, weight and mv square by l act in this direction, so tension should be equal to this. So if tension equal to this plus this, and also we get this, if putting theta equal to 0 at here, so tension at a equal to mg plus m v square a by l. This is equation 1. So we get the tension at a. At c, for position c, so this is the position at a, tension at a equal to this. And for position for position C, theta equal to what? Theta equal to 90. So put theta equal to 90 at here. Tc equal to mg0 cos 90 0 plus m v square by L. So this is the tension at C. Tension at C equal to m v square by L. Velocity at C is this. Velocity at A is this. Along this direction, velocity at C is along this direction, and velocity at D is along this direction. Now what is for position? For position D, for position D, what is theta? Theta equal to 180 degree. Theta equal to 180 degree. This theta equal to 180 degree. For this angle is theta equal to 90 degree. So put theta equal to 180 degree at here. What is the value of cos 180? Cos 180 equal to -1. So if we put -1, what is tension B equal to minus mg plus m vd square by L. Okay, so this is the tension at B. Tension at B. Equation 1, equation 2, equation 3. Suppose equation 3. mvd square by L minus mg. So this is the tension at different position. Now from the equation we see that tension at lowest position is maximum because mg plus this, and tension at D position this minus mg. Mg is minus and also D is minimum. D is minimum because as the stone goes upward, its velocity decreases because its kinetic energy decreases, potential energy increases, total energy conserves. So velocity, when the stone goes upward, then its velocity decreases. So that's why this is less. Also weight is subtracted, so tension is minimum. Maximum T is maximum at tension is maximum at position A, and T maximum will be m v square by L plus mg. And what is the minimum? Minimum T minimum occurs at position D. This T minimum will be m vd square by L minus mg. This the maximum and minimum tensor occurs at this position. This is maximum, here maximum tensor, here minimum tensor. So now important condition is that what is the minimum velocity at here, so that the stone can take one complete rotation. The stone can take the one complete rotation. What is the minimum velocity required at the position A? That is, suppose the stone is projected with less velocity, then the stone can climb up to this height, and if the velocity is more, then this, if is little more, then the climb up to this. And so what is the velocity required? So that velocity required, minimum velocity, so that the stone can climb up to this value, and if the stone can climb at the top position, then automatically due to inertia motion it goes down due to inertia motion it goes down. So now if it reaches at here, then automatically it goes down. So mass can complete one rotation, so the stone can complete one rotation. Now what is the velocity is required at here? Minimum velocity. So now we what is the minimum velocity at A and at D? This is position D, this is position A, for which the stone of mass can complete one rotation. So if this is the stone, this is center. So to complete rotation, for complete rotation, tension at D should be greater than equal to 0. This is the condition. Tension should be greater than 0. If tension is less than 0, what happens? The string becomes slack. If tension is less than 0, the string becomes slack and it moves downward. So it falls. If the tension less than 0, if T less than 0, then string slacks, that is loose, string becomes loose and the stone falls. And it cannot complete one rotation. So for complete one rotation, tension should be greater than equal to 0. So we find minimum velocity. So for minimum velocity, tension should be equal to 0. Now Td equal to 0, what is the tension? Tension becomes mv square by r minus mg, this is d point velocity, equal to 0. That is Vd equal to root over r into g. Here r equal to root over lg. So this is the minimum velocity at d point. This is the minimum velocity at d point. Now to maintain this velocity, what is the velocity required at this lowest point? Now we find the problem. Velocity is root over lg required. Now what is the velocity required at here? So that when the body reaches at the point D, its velocity becomes this. Now as the body goes up, its kinetic energy decreases and potential energy increases. So we apply always, when in the motion of vertical plane, change of kinetic energy is equal to change of potential energy. We use this equation. So for the motion of body in the gravity or in vertical plane, we use this equation, change of kinetic energy equal to change of potential energy. Now change of kinetic energy means half m v square minus vd square. Change of potential energy means mg into l. What is height? Height is 2l. So 2l. Now cancel so va square minus vd square equal to 4lg. So va square equal to vd square plus 4lg, which is equal to lg plus 4lg, that is 5lg. So va equal to root over 5lg. This is the minimum velocity required at a point. So this is very important theory. This is minimum, not any value, minimum velocity. If you are asked that minimum velocity required, then this. If velocity greater than v minimum, that is root over 5 lg, then obviously it can complete the rotation. V greater than root over 5 lg, easily it can complete the rotation, and tension also more than root over tension is more here. But for complete repulsion, what is the minimum velocity? Required to complete one rotation, such that the stone can complete one rotation? This is the answer. If v greater than this, then the stone can easily complete the rotation, but minimum velocity is this. If v less than, so v greater than can easily complete rotation, and v less than root over 5 lg, stone cannot complete rotation. Fine. If v is less than this value, then it cannot climb the top position. Before reaching the top position, here tension becomes 0, tension is less than 0, and the stone falls down, or the string slacks down, the string loose and the stone falls down. Okay. If you are asked that tension at D and at A at minimum velocity, that is when tension when V is minimum, so tension at a what, mg plus m v square by l, just put V equal to 5 lg, we get, so Ta equal to this, okay, will be obviously 0 at minimum velocity. Now what is the tension at tension at C point? This tension should be equal to mvc square by L. So tension at C equal to mvc square by L, because here this tension should be equal to this force. Weight cannot influence the tension, weight is act perpendicular, so weight cannot influence this tension. Now what is the velocity at C point? So now apply to find the Vc, we apply again change of kinetic energy equal to change of potential energy, which is half m Vc square. Va is more, so Va square minus Vc square equal to change of potential mg into L. What is L? What is L? Now, height of this point, height of this level from this is L, mgl. So V square cancel, cancel, so 12g plus Vc square. So Vc square equal to V square plus V square minus 12g, that is Vc equal to root over 3lg. So this is the velocity at C point. Now put Vc equal to this, we get LL cancel, so tension at C equal to we get 3 mg. Tension at C we get T equal to this. Mass M is tied, a stone is tied by string of length L, and if this stone is projected with velocity u, at which angle, if the stone is projected with velocity u and when it reaches at angle theta, find the tension of the string, find tension at an angle theta with vertical. So this is the question. Mass is projected with velocity u, and when it reaches at an angle theta with the vertical, what is the tension of the string? So L is given. Now here we have to apply what height the stone ascends. What is the height ascends by the stone? So this height we have to calculate. First we calculate the velocity. What is the velocity at that point? So velocity at that point v theta. To calculate the v theta, we apply change of kinetic energy equal to change of potential energy. Always use this equation when solve the problem in vertical plane. Change of kinetic energy equal to change of potential energy. So half change of kinetic energy v theta square my half m, so half m u square minus v theta square equal to change of mg into height. Now you have to derive the height, so you memorize the height. What is the formula of height here? You memorize this so if this is O, this is A, this is B, what is height? H equal to AB. Now AB equal to OA minus OB, OA minus OB, OA equal to L, and OB equal to what? OB equal to, from this triangle, suppose this is C point, so from triangle OBC, what is cos theta? Cos theta equal to base is OB, base by hypotenuse, this is L. If the string is remain same, the string remains same, and the string is inextensible, length remains same, so length remains same, that is OB equal to L cos theta. OB equal to L cos theta. Now put OB equal to L cos theta here. Okay, L minus L cos theta. So H equal to L minus L cos theta. Now put here H equal to L minus L cos theta, V theta square. So cancel both side. So U square minus V theta square equal to 2GH. What is H? H equal to L into 1 minus cos theta. So this is the velocity at theta. Now change of current energy, change of potential energy, mgh. H equal to what? L minus L cos theta. L minus L cos theta. Put here L. Put H equal to L minus L cos theta. Now V theta square equal to U square minus this. So this is the velocity at angle theta. Tension at theta equal to mg cos theta plus m v square by L, m v theta square by L, m v theta square, which is equal to mg cos theta plus m this. V theta square equal to this, u square minus 2lg 1 minus cos theta mg cos theta plus this is L. So m square by L minus 2 mg 1 minus cos theta, which is equal to cmg cos theta, 3mg cos theta, mg cos theta plus 2mg cos theta, 3mg cos theta minus 2mg plus m u square by L. So you get this type of equation. You are asked to find the height at which tension equal to weight of the body. Tension equal to weight of the body. Now cos theta equal to, you can put cos theta equal to. So if this question, find the height from the ground. Find height from ground at which tension of string is equal to the weight, of the stone. Okay, fine. Find the height at which the tension is equal to the weight of the stone. What will be the answer? We find the tension is this. So if the body is projected with velocity u, what is the height at which the tension is equal to weight? So put here T equal to mg and 3mg cos theta. Now what is the cos theta? The value of cos theta equal to base by hypotenuse, that is, what is cos theta? Cos theta equal to, this is L minus, if this height is h, so this length is L minus h. Cos theta equal to L minus h by L. Okay, so put here cos theta equal to L minus h by L minus 2mg plus m u square by L. So mg cancel from both sides. So g equal to 3g 1 minus h by L minus 2g plus u square by L. 3g minus 2g equal to g cancel. So 3gh by L equal to u square by L. L cancel. So u equal to root over. So h equal to u square by 3g. H equal to u square by 3g. So this is the answer. The height h equal to u square by 3g if the stone is projected horizontally with velocity u, at this height tension becomes equal to mg. Find this derivation. So at the height h equal to u square by 3g, at the height h equal to u square by 3g, tension is equal to this. So at which angle tension become 0? At which angle tension become 0? If this is take ground, if you take this is ground level, suppose this is ground level, at which height from ground level tension becomes 0? Tension becomes 0. So here t theta equal to 0, put here t theta equal to 0. So t theta equal to 0, that is 3mg cos theta minus 2mg plus m u square by l equal to 0. Now put cos theta equal to what? 1 minus h by l, 1 minus h by l minus 2mg plus m u square by l equal to 0. So 3mg minus, that is g, 3mg minus 2mg, mg minus 3mg h by l plus m u square by l equal to 0. So from this you get h. From this you get h. Okay, this simple calculation, you get h equal to this. And mass of the stone is this. If the string is held along the horizontal level and it is released, and when the stone is at lowest position, what is the tension of the string? T equal to what? L is the length of the string. What is the tension of the string? This or this? So from this the stone is released. When it reaches at angle theta, what is the tension of the string? And when it reaches at lowest position, what is the tension of the string? So suppose this is C point, this is A point, TC and TA what? TC, TA what? Here mass, m is the mass of the string. Now this angle is suppose alpha. So first I solve this problem. Now this is simple. Here u equal to 0, so we can find the velocity at here. Velocity equal to change of kinetic energy equal to change of potential energy. Change of kinetic energy is half mv square minus 0 equal to potential energy mgl. So v square equal to 2lg. V square equal to this. Now the tension at this point is, what is the tension? Tension will be mv square by l plus mg. Tension will be this plus this. So tension at lowest position equal to m v square by l plus mg, which is equal to plus mg. Okay, l cancel, so this equal to 3 mg. So this is the answer. Now solve this problem. Suppose the stone is released from this position, that is at an angle alpha with horizontal level. This angle, this is released when the stone makes an angle alpha. Suppose this is alpha. For convenience we take this is the angle alpha. When the strings makes an angle alpha with the vertical, then what is the tension of the string? And when it is at position A, what is the tension of the string? TC and TA find. So first, to find the tension, student, always in this type of question, always find the velocity. Always first find the velocity at different point. So to find, this is the important points, to find velocity at different point. At different point, use the equation change of kinetic energy equal to change of potential energy. So this is the very important tricks to find the velocity at different position point. Use the equation this, change of kinetic energy, change of potential energy. Okay, if you find the velocity, because for tension T equal to, always use mg cos theta plus mv square by l. So here velocity is variable, velocity is different at different point. So first find velocity at any point, velocity at any point. Tension, if you are asked the tension at that point, tension at any point, then you first find the velocity at that point. This is fixed, this is fixed. So to find the velocity at any point, take this equation. This equation is important. Take this equation. So when we solve this type of question, now we find first velocity at that point. To find the velocity at that point, we have to find the height. This height, we have to find this height. Suppose this is h, this to this. What is h? H is equal to, from this angle alpha, we get that this, suppose this is h1 and this is h2. So h1 equal to, this length is L, this length is L, this length is L, and this length also L. So the, suppose this is O, suppose this is point, this is point D, this is a D, this is point P, this is C, this point. So from OPD, from triangle OPD, what is H1? H1 equal to H1 by L equal to sin alpha. H1 by L equal to sin alpha. So H1 equal to L sin alpha. L sin alpha. So H1 equal to L sin alpha. Now from triangle OPC, what is? So this height and this height equal H2 equal to O. Suppose this point is, this is a point, suppose this point is E point, OE, which is equal to L cos alpha, So H equal to H1 plus H2, which is equal to L sin alpha plus cos alpha. Okay, first you find this height, this. Now take the change of kinetic energy equal to change of potential energy. So change of kinetic energy, half m vc square minus 0, because the body is released from here. So u equal to 0 here. Velocity is c. This equal to change of potential energy mg into h. What is h? H is equal to this. So cancel this mm. So vc square equal to 2lg. So this is the velocity. Now so tension at c will be mg sin alpha, mg cos alpha. If this is theta, so this is mg, this is alpha, so mg cos alpha plus mv c square by L, which is vc square equal to this 2lg into sin alpha cos alpha. L cancel, 2lg sin alpha plus cos alpha. So this is the answer, 2mg cos alpha plus 3mg cos alpha plus 2mg sin alpha, or take common mg c cos alpha plus 2 sin alpha. So this is the answer. Now at the a point, for that point A, this is L and this is L sin alpha. For the point A, height is, so this is the answer. Okay, so for point A, what is the height? This to this height, this is L length and this is L sin alpha, because this is L cos alpha, this is L sin alpha. So at point, for point A, what is the height? SD is equal to L plus L sin alpha. Now similar process, change of kinetic energy equal to change of potential energy. So half m v square minus 0 equal to change of potential energy mg h dash, which is equal to mg L 1 plus sin alpha. Take cancel mm both side. So v square equal to 2lg 1 plus sin alpha. So now tension at A equal to mg, here cos 0, mg total weight is mg plus m v square by L which is equal to this. Okay, this is the answer. Next, of course, problem is, suppose this is a sphere, this is a sphere, and is a sphere, and a ball is raised at here at the top, suppose the ball is small, push by small force, pushing by small force, small, very negligible force is negligible. So when the ball is pushed, now it moves along the surface, at a particular point. The ball can leave the surface. So find the height from ground. Suppose this is ground. Find the height from ground at which ball can leave the surface, or the ball can leave the surface. So this is fly, this leaves the surface. Why the ball leaves the surface? Because velocity is maximum, centrifugal force act in this direction. So the ball at a particular point, ball can leave the surface. The ball can leave the surface. So what is that height? Now from, so this is the center. So if this angle is theta, now what is the and length of the, suppose radius is r here and this is r, so this height equal to r cos theta. Now what is the height here? This height equal to h equal to, we get h equal to r minus r cos theta, we get this height equal to this to this, that is at the level of this ball, this to this height equal to r minus r cos theta. Now we always, now first draw the free body now first so what are the different force acting on the ball? Here, if the velocity at here is v, then a centrifugal force act in this direction, which is equal to mv square by r. Weight act in this direction, this is weight, and the another force is normal reaction, n act in this way, mg. So if this angle is theta, then this angle is theta, so mg cos theta act in this direction. So what is the equation? The ball is, so there is no motion along this direction, so n plus mv square by r equal to mg cos theta. As there is no motion in this direction, so net force along this direction will be 0, that's why this equal to this. Now what is the condition for leaving the surface? The condition is n equal to 0. When the stone leaves the surface, n equal to 0, normal reaction should be 0. Okay, so m v square by r equal to mg cos theta, which is equal to v square, that's from this v square equal to rg cos theta. Now apply change of kinetic energy equal to change of potential energy, which is half m change of kinetic energy. Here velocity is here and velocity is here 0, so half mv square minus 0 equal to change of potential energy mg into this height is this, h equal to, what is h equal to this, put here r into 1 minus cos theta, so mg cancel, and put v square equal to rg cos theta, equal to 2 rg 1 minus cos theta. Okay, now RG cancel. So 3 cos theta equal to 2, that is cos theta equal to 2 by 3. Okay, cos theta equal to 2 by 3 we get. So remember this angle, cos theta equal to 2 by 3, the ball leaves the contact. So height, what is height? H. This height H equal to r minus r cos theta 2 by 3, that is r by 3. So this height is r by 3. Now what is the ground, what is the height of this level from the ground? This height will be 2r minus h. So answer is 2r, because this to this is 2r. So answer is 2r minus this to this 2r minus h, which is equal to 2r minus h equal to r by 3, that is 5r by 3. So this is the answer. Now here a important condition is given. Here a important condition is giving. What is the condition of looping the looping? What is the condition of looping the loop? That is, if a stone is projected at lowest level at bottom with velocity u, then what is the condition for that such that it can complete one loop? So the condition is that velocity at the lowest level, I have derived already, velocity is greater than equal to root over 5 h. This is the condition. And condition at the what is the velocity at topmost position, this equal to this, and condition is that here normal reaction should be 0. Normal reaction should be 0. So this is a sphere. If a body is projected at lowest level with velocity u, then here normal reaction is 0, and velocity, if velocity equal to this, then it can loop the circle, and minimum velocity required equal to this. And at the lowest level, what is the normal reaction here? Normal reaction will be 6 mg. So you just copy this chart, formula chart. This is not required here. Just remember this, u equal to velocity here this, and normal reaction had at here equal to 6 mg. Now what is the condition of leaving the circle? That is, if a stone is projected in a sphere, if a stone is projected horizontally within a sphere, then at which angle the ball can leave the contact surface? That is, leaving the circle, this circle, at which angle the ball can leave the surface? The condition is this, u less than root over 5 at g. That is, if u equal to root over 5 at g, then the body here the velocity here the normal reaction equal to 0. But if u less than root over 5 at g, then it cannot reach the topmost position. Before reaching the topmost position, normal reaction here will be 0. But the condition is that normal reaction equal to 0, but v not equal to 0, velocity will not be 0. So this is the condition. If we apply this theory, then we get the relation is this. So condition of leaving the circle is this. Now, and the height should be greater than r, because this is r. So height should be greater than r, and angle is from 90 to 180. If we take the angle from this, angle will be theta greater than 90 and less than 180. So theta is less than 180, greater than 90 at here. At this angle the ball leaves the contact surface. So normal reaction equal to 0 and velocity not equal to 0. So when the ball leaves the circle, the movement of the ball will be parabola, that is just this parabola. Now condition of oscillation, when u less than root over 2 gr, then the ball will oscillate along the circle. And condition of oscillation is that velocity at highest point, velocity at extreme position is 0, because for oscillation we know that for pendulum, suppose take a pendulum, velocity at extreme position is 0. So condition is that velocity is 0, but tension, there should be tension not equal to 0. So this happens when h less than equal to r and projected velocity is less than equal to root over 2rg. So you remember this condition. This is enough for circular motion in vertical plane. I hope you can solve any type of question related to vertical plane. Student, to get such type of video, subscribe my channel. Okay, thank you.